So very good afternoon to you dear students. So we are going to begin a new chapter called the atomic structure. So we have already learned about matter in the previous classes. So today we are going to discuss about atomic structure. Before getting into this topic, I would like to get you certain terms that are very essential while we talk about this, which we have already learned in 6th standard, 7th standards and 8th standard classes. So we all have learned about atom in detail. An atom is made up of protons, neutrons and electrons. And the discovery of protons, neutrons and electrons we have discussed about it already. So I am just going to give you a timeline of happenings that took place from John Dalton onwards. Okay. So the idea about an atom was suggested by John Dalton in the 18th century. So the theory of John Dalton, according to John Dalton, atoms are indivisible particles of an element that cannot be further divided into. That is what is Dalton's atomic theory. So when we just talk about atomic structure, what are we going to discuss about in this topic, atomic structure? The discovery of protons, neutrons and electrons and the subatomic particles, we have already learnt about it. Okay, but where are these subatomic particles present inside an atom? So that is what we are going to discuss for today. So John Dalton in the 18th century, when he suggested about atoms, the idea about subatomic particles was not there. Okay. So after John Dalton, there were many scientists who have worked over the structure of atoms. So John Dalton said that an atom is the smallest indivisible particle of an element. This is not Dalton's theory. ஆனால் நாளடைவில் என்னாச்சு? Okay, very few years after John Dalton's theory was given to the world, okay, there were few scientists who worked over atomic structures and they said that an atom is not the smallest particle. It can be further divided into protons, neutrons and electrons. So the discovery of subatomic particles arise the question, where are these subatomic particles present inside an atom? Okay, so what you see on the screen is postulates of Dalton's atomic theory. All matter is made up of very tiny particles called atoms. Understand? Matter is made up of tiny particles called atoms. Atoms are indivisible particles. So what does it mean? An atom cannot be further divided into. It is the smallest particle. அப்படின்னு சொல்றாரு John Dalton. So the example that we can give you is, take a piece of chalk, keep on breaking it into smaller pieces. We will arrive finally. Now, what's it finally, we will arrive at a smallest particle that cannot be further divided into. And what is that called? That is called an atom, according to John Dalton, which cannot be created nor destroyed in a chemical reaction. An atom cannot be created nor destroyed. This is the smallest particle that takes part in a chemical reaction, which cannot be destroyed. The third point, atoms of a given element are identical in mass and chemical properties. So what is this explanation about John Dalton? What is he trying to say the world about? For example, if you take a small piece of iron and you study the particles of iron, what will be iron made up of? Iron will be made up of atoms of iron. When you compare the number of atoms present in an iron with each other, you will know that they are identical. Atoms of iron compare the atoms of iron will be identical by nature. If you take an atom of silver, compare them with an atom of another silver, they will be identical. But atoms of silver, when compared with atom of iron, they both need not be identical. John Dalton. So John Dalton's theory about atoms நாளடைவில் disprove பண்ணிட்டாங்க. எப்படி disprove பண்ணாங்க அப்படின்னா, an atom can be further divided into அப்படின்ட்டு எப்ப மைக்கேல் ஃபாரடே அப்படின்னு ஒரு சயின்டிஸ்ட் என்ன பண்றாரு, he studies about electrolytes. Electrolytes are liquid conductors. So when he started learning about electrolytes, the conductivity எதனால ஒரு electrolyteல conductivity எதனால நடக்குது அப்படின்னு அவர் ஆராயும் பொழுது he found that atoms had subatomic particles and inside that atom the presence of protons, neutrons and electrons were discovered later. இதுக்கு அப்புறமா என்ன ஆயிடுச்சு அப்படின்னு பார்த்தோம்னா, இந்த protons, neutrons, electron ஒரு ஆட்டம்ல எங்க இருக்குது, where is it present அப்படின்ற क्वेश्चन ரைஸ் ஆகும்போது many people started working on its atomic structure. So atomic structure தேட பார்த்தா சொல்ல போறோம் அப்படின்னு சொன்னா அங்கதான் என்ன இருக்குது, an atom is a invisible substance. நம்மளால பார்க்க முடியாது, ஒரு பொருளை பார்க்க முடியல அப்படின்னு சொல்லும்போது அந்த பொருள் எப்படி இருக்கும் அப்படின்றத நம்மளால சரியா சொல்ல முடியாது. அதனால எப்படி ஒர்க் பண்றாங்க, அதோட கெமிக்கல் பிஹேவியர், ஓகே, how they react with the different substances, இதை அடிப்படையில வந்து அதோட ஸ்ட்ரக்சரை கணிக்கிறாங்க. they are just giving an assumption. it is not exactly atom இப்படிதான் இருக்கும் அப்படின்னு அன்றைய காலகட்டத்தில் அவங்களால சொல்ல முடியல. இதுல பார்த்தோம்னா ஒரு டைம் லைன் சார்ட் மாதிரி ஜான் டால்டனுக்கு அடுத்தது many scientists like the J.J. Thomson, Rutherford, Neil Bohr, okay, these people worked on the structure of atoms. Understand? We are going to discuss about them in detail in this lesson. Understand? First we will just discuss about J.J. Thomson's atomic model. அவர் என்ன தியரி சொல்றாரு அப்படின்றத பார்ப்போம். So what you see on the screen, that's an image of J.J. Thomson. Okay. இவரோட தியரி என்ன அப்படின்னு சொன்னோம்னா, it is a plum pudding model of a atom. That is the idea suggested by J.J. Thomson. J.J. Thomson என்ன சொல்றாரு, it is a plum pudding model. plum pudding model ஒரு plum cake மாதிரி இருக்கும். plum cake நம்ம எல்லாரும் பார்த்திருக்கிறோம். plum cakeல வந்து அந்த resins இருக்குது இல்லையா, ஓகே, இல்ல plum that will be scattered over the cake here and there. அப்ப அதை எதுக்கு ஒப்பிடுகிறார், he is saying that positively charged region, அந்த கேக்க வந்து ஒரு positively charged region ஆகும். the entire cake is considered to be a positively charged place where the electrons are embedded on its surface என்ற அதுக்கு மேல வந்து எலக்ட்ரான்ஸ் எம்பெட்டடா இருக்குது அப்படின்னு சொல்ல வராரு. So J.J. Thomson also says it to be a watermelon model of an atom. watermelon நம்ம எல்லாரும் பார்த்திருப்போம், தர்பூசணி ரெண்டு ஸ்லைஸ் பண்ணோம்னா, தர்பூசணி எடுத்து ஸ்லைஸ் பண்ணோம்னா the red color region பார்ப்போம். அந்த red color regionல கருப்பா விதைகள் இருப்பதை நம்ம பார்க்கிறோம். Okay, we are able to see the black seeds embedded on the red color region of the watermelon. So the red color part is considered to be the positive region of the atom where protons are present. And where are the electrons? He compares that to the seeds of the watermelon. Okay, they are the electrons in an atom. So this is J.J. Thomson's theory of the atomic structure.
The laws of chemical combinations created ripples in the stagnant pool of chemistry. They enabled scientists to carry out various experiments that helped in forming strong foundations in chemistry. However, the laws still needed experimental evidences and proofs. Only then would they be accepted. It was around the first decade of the 19th century that a chemist and a physicist from England named John Dalton was successful in answering many questions. He proposed a theory which was then known as the Dalton's atomic theory. With this theory, many concepts regarding matter, composition of matter, atoms, and even combinations of atoms resulting in compounds were better understood. Okay, let's first take a very quick look at the 6 major postulates of his theory. First, he said that all matter is made up of very tiny particles called atoms. Secondly, he suggested that atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Third postulate was, atoms of a given element are identical in mass and chemical properties. Similarly, fourth postulate was that atoms of different elements have different masses and chemical properties. Fifth postulate stated that atoms combine in a ratio of small whole numbers to form compounds. And lastly, the relative number and kinds of atoms are constant in a given compound. I know I just rattled off the postulates. Don't worry. Let us now understand each postulate one by one by taking the same example of elements A and B giving rise to compound C. The first point stated that all matter is made up of very tiny particles called atoms. It means that when we go on dividing matter into smaller and smaller sections, what we get at the end is atoms. So can we say that elements A and B are made up of atoms? Yes, in fact, compound C is also made up of atoms that have combined together. So the first postulate was very easy to understand. The second postulate was that atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Now, what do we mean by this? Yes, it means that atoms are like the fundamental units. Dividing them further is not possible. Also, in a chemical reaction, atoms may combine together to form new units. However, no new atoms can be created and existing ones cannot be destroyed. So in this case, the atoms of element A and B are just combining to form compound C. So can we say that no new atoms are formed in this case? Yes, and similarly, no atom is destroyed. Let's move on to the third one now. The third postulate states that atoms of a given element are identical in mass and chemical properties. If we zoom into the element A, we find all the atoms that make up element A are just the same. And in what sense are these same? The atoms have identical mass as well as chemical properties. In simple words, the third postulate states that all atoms of a given element are identical. And does this explain the fourth postulate too? Yes. The fourth postulate states that atoms of different elements have different masses and chemical properties. So are we able to notice that atoms in element A are different from those in element B? Absolutely. And in what sense are they different? Atoms in element A and B have different masses and even different chemical properties. In simple words, it states that atoms of different elements are different. The fifth postulate states that atoms combine in a ratio of small whole numbers to form compounds. Now, what do we mean by this? In this chemical reaction, we find elements A and B reacting and giving us the compound C. If we observe well, a unit of compound C has 2 atoms of element A and 1 atom of element B, right? So aren't these whole numbers? Yes. This means that in any compound, the elements are always present in a ratio which comprises of whole numbers. You will not find half or 3/4 atom combining with the other. In case of water, we always have 2 hydrogen atoms and 1 oxygen atom combining to form 1 unit. In 1 unit of carbon dioxide, we have 1 carbon and 2 oxygen atoms. The same holds true for all compounds. The number of atoms of a particular element in a compound will always be a whole number. Now for the last one. The sixth postulate states that the relative number and kinds of atoms are constant in a given compound. The same explanation that compound C has 2 atoms of element A and 1 of element B makes us understand this. Yes, if we scan compound C, we will always find 2 atoms of element A and 1 atom of element B in a single unit. And this is applicable for all compounds. We've already looked at 2 examples, water and carbon dioxide. In case of 1 unit of water, we always have 2 hydrogen atoms and 1 oxygen atom. And in a single unit of carbon dioxide, we have 1 carbon and 2 oxygen atoms. Carbon monoxide has 1 atom of each, that is carbon and oxygen. While 1 unit of ammonia always has 1 nitrogen atom bound to 3 hydrogen atoms. So the number of atoms will always be constant in a unit of a particular compound. In a nutshell, all these postulates help chemists to further understand behaviors of elements and the compounds formed from them. But for understanding these elements and compounds, knowing the concept of atoms is necessary. Let's get to know what exactly these atoms are, how they exist, their mass, and many such interesting concepts in the upcoming videos.
Thomson's model of atom. Atoms are the basis of chemistry and of everything in the universe. Atoms are the general term used to describe pieces of matter, that is, matter is composed of atoms. That brings us to the question, what is an atom? An atom is a basic unit of matter that consists of a dense central nucleus surrounded by a cloud of negatively charged electrons. Studies of atoms dates back to as far as the 5th century BC. Democritus, a Greek philosopher, described atom as that which cannot be cut up further. Acharya Kannada of India defined atom as eternal and indestructible and which cannot exist in free state. John Dalton proposed that atom was indivisible and indestructible, but this can only be said so if it is not composed of further particles. Are there particles that are smaller than an atom? Sure, there are. The discovery of the fundamental particles, protons, neutrons, and electrons inside the atom led to the failure of Dalton's atomic theory. This also proved void Democritus's and Kannada's theories that atom is indestructible. Who were the people behind the discoveries of these particles? They were none other than James Chadwick, who discovered neutron, Eugen Goldstein, who discovered proton, and J.J. Thomson, who discovered the electron. So how do we explain the arrangement of protons and electrons inside an atom? To explain the arrangement of protons and electrons inside the atom, J.J. Thomson prepared a model for the structure of the atom, known as Thomson's model of atom. The model of an atom proposed by Thomson is similar to a Christmas pudding. In this model, electrons are arranged in a sphere of positive charge like plum in the spherical Christmas pudding. So it is called plum pudding model of an atom. Do you know of any fruit that we can compare Thomson's atom model to? Well, it can be compared to a watermelon. The negative charged electrons are like seeds embedded all over the positively charged sphere that is compared to the edible part in the watermelon. Thus, Thomson proposed that an atom consists of positively charged sphere and the electrons are embedded in it. The negative and positive charges are equal in magnitude, so atom as a whole is electrically neutral. Things to remember. Atoms are the basis of chemistry and of everything in the universe. Democritus described atom as that which cannot be cut up further. James Chadwick discovered neutron, Eugen Goldstein discovered proton, and J.J. Thomson discovered electron. The model of an atom proposed by Thomson is similar to a Christmas pudding. In this model, electrons are arranged in a sphere of positive charge like plum in a spherical Christmas pudding. The negative and positive charges are equal in magnitude, so atom as a whole is electrically neutral.